Everyone, welcome back to my YouTube channel. Today we are going to see Maharashtra State Board Class 8 Subject Science Chapter number 19 Life Cycles of Stars. In a previous videos already we have covered up different chapters of the Class 8. In this we will study about stars, how they are getting birth in the universe, how they are evolved, and what happens when the stars are dying, or what is a life cycle, or means the complete entire life cycle of the star we will study from their birth till their death, how they are getting evolved. That also we are going to learn in this particular chapter. When it comes for the space, everyone is having a curiosity to know about different astronomical bodies which are present in the space. And in that, the most important and the most discussed astronomical body is a stars. Now, first we will understand what exactly is a star. In the night, when we look in the sky, we get a or we observe the various or the huge number of the small stars. But is it real they are so small? Then the answer is no. They are not so small. They are at a very far distance from us, and that's why they look very small in a size. We had already studied about the solar system, our solar system. In that we have the sun at the center and the 8 planets are revolving around it. This entire system is called as the our solar system. In that, the sun what we have is nothing but the star of our solar system, and it one is the nearest to our earth. When we talk about the galaxy contains the number of solar systems. Our solar system is present in a galaxy which we call as a Milky Way galaxy or the Mandakini. You can see here the name is given, that is the Milky Way and Mandakini. Now the shape of the galaxies, that may be spiral, elliptical and irregular galaxy. So these are the three different types of the galaxies which are possible, which we can get in the universe. There are a huge number of the galaxies which are present in the universe. So what we have at the first, we have the universe. In that universe we have a multiple galaxies or the numerous galaxies, and in the galaxies containing a solar systems. Now the further part what we have to study under this, in the night when we look into the sky, we see only the planets and stars. There are the various telescopes which are used on the Earth's surface to observe this particular stars or the planets. Now the next what we are going to talk about is the properties of these stars. At the night we can see almost around 4,000 stars with our naked eyes. If we have the no moon day, then in that particular night we can see almost around 4,000 to 5,000 stars in the sky with the naked eyes, means without use of any optical instrument. When we talk about these stars, stars are the magnetic sphere of a hot gas. Some properties of the sun are given below, and hydrogen makes up 72% of the mass of the sun, while helium is 26%. The rest 2% is made up of the elements heavier than helium. So basically when we talk about these stars are nothing but the collection of the hot gases. We have different stars with a different mass, different density, different sizes. Here, they have given the information about the properties of the sun, the mass, radius, surface temperature, temperature at the center, and then the age of the sun they have given. So, mass of the sun, when we talk about, it's a 2 into 10 raised to 30 kg. Radius is a 6,95,700 kilometer, and the surface temperature is a 5,800 Kelvin. It is a surface temperature. Temperature at the center, that is a 1.5 into 10 raised to 7 Kelvin, and the age is almost a 4.5 into 10 raised to 9 years. Here some more information they have given is about our galaxy has about 10 raised to 11 stars. Its shape is like a disk with a bulge in the center, and its diameter is about 10 raised to 18 kilometer. The solar system is situated at the distance of a 2 into 10 raised to 17 kilometer from its center. So this may be asked to you, this question may arise, that what is the distance of the our solar system from the center of the galaxy? Galaxy is rotating around an axis passing through its center, and the perpendicular to the disk, its period of rotation is about 2 into 10 raised to 8 years. Means this much time it takes to complete one rotation. Now the further is, there are the different kind of these stars, and that classification is done on the basis of the mass. The mass of the sun is about 3.3 lakh times that of the earth, and its radius is 100 times that of the earth. Other stars have a masses between 1/10 of mass of the sun, and that of the sun and 100 times of the sun, and the radii can be 1/10 to the 1,000 times of the radius of the sun. Means we have a smaller than the sun also, and we have a bigger than the sun also. So there are a different kind of the stars. You can see that the sizes they have shown with the help of a picture over here, the comparative pictures. The red giant stars, you can see the huge structure of it, and sun is so small in front of it. And the supergiant, that is, and there is a white dwarf also, which is very small, like a dot in that particular picture. Now when we talk about the age of the sun, and other stars, which is the time elapsed after their formation, can be between a few million years to a few billion years. So you can imagine how long they are present in the universe. From the million years to the billion years is a range of their ages. Further is properties of the earth have led the scientists to conclude that the property of the sun have remained unchanged over its lifetime, that is the past 4.5 billion years. According to the studies made by astronomers, these properties will slowly change in further after 4.5 billion years. Means almost whatever the time has elapsed for the age of the sun, almost a similar time it will take to show some changes in the properties of the sun. Further is the birth of stars, how the stars are getting birth. That there we are going to discuss now. The huge clouds of gas and dust are present in the empty spaces between stars in the galaxy. Because when we talk about the galaxies, in that the different number of the stars are present. So vacant spaces between the number of stars are filled with the hot gases or the low temperature gases or the dust particles. All these are present, and we have a huge cloud of stars, and these are called as the interstellar clouds. When we talk about this interstellar clouds, the distance or the size of this is measured in a light year. Now the question comes, what is a light year? In a simple way, when we talk about the light year, is nothing but a distance traveled by light in 1 year, means in a 365 days, how much light can travel, that distance is known as the 1 light year. And as we know, the speed of a light is nothing but the 3 into 10 raised to 8 meter per second. In a simple terms, it is a 3 lakh kilometer in 1 second. So with the help of that, if we are calculating it for the 1 year, then it equals almost 9.5 into 10 raised to 12 kilometer. So this particular distance will be called as the light year. Means simple calculation, if I want to show over here, then 3 lakh kilometer it travels in a 1 second. So into 60. So this is the distance in 1 minute. We want for the 60 minute. We want it for 24 hours in a day, and there are 365 such days. And when you will calculate this, then you will get the result as 9.5 into 10 raised to 12 kilometer. So this distance is called as the 1 light year. A distance traveled by the light in 1 year. Now, when we talk about this interstellar clouds, so their sizes, their width, what we have is a few light years. So you can imagine what is a huge size they have. Because if 1 light year is 9.5 into 10 raised to 12 kilometer, then few light years will add up a huge width. And these gases goes under the contraction. You can see they are mentioned over here. Due to some disturbances, these clouds starts contracting. Because of the contraction, their density starts increasing. Their density increases. Definitely, if something is contracted, density will increase. And this dense sphere of the hot gas is formed from the cloud. Once the temperature and density at the center of a sphere increases sufficiently, then the nuclear energy generation starts. Because when the temperature is increasing and the density is increasing, definitely there will be a nuclear reactions, or the nuclear energy will get liberated, and the gas sphere becomes self-luminous. And due to that energy, what will happen? The temperature will rise and it will be self-illuminated. Means like a electric bulb. It will start to give out a light. Star is formed, and that will produce a star, because if the luminous is there, means it is a star. In the sun, this energy is generated by the fusion of hydrogen nuclei to form helium nuclei. So in our sun, what exactly is happening? The hydrogen gas what is present in the sun is combining together and forming the helium nuclei. In this process, it releases a huge amount of energy, and at the center of a star acts as a fuel, and energy is generated by the burning of this fuel. So light takes about, this just as an extra information they have given over here, light takes about 1 second to reach us from the moon, while it takes 8 minutes. So you can imagine the distance between the sun and the earth as compared to the sun and moon. So from the moon, it takes only a 1 second to reach on the earth's surface. Whereas when it comes for the sun, it takes almost 8 minutes. Means the light which is starting from the sun, it takes almost 8 minutes to reach on the earth's surface. And it takes 4.2 years to reach us from the star Alpha Centauri, which is the star closest to the sun. So name of the closest star to the sun is a star Alpha Centauri. Now the further is, when a gas sphere contracts, its temperature increases. This happens because of the transformation of its gravitational potential energy into heat energy. Now the further is a stability of stars. Stars are formed, but they should be stable, no? Now the further is, if we burn an incense stick in one corner of the room, the fragrance spreads all over the room instantaneously. Instantaneously means immediately. Similarly, when we remove the lid of a vessel containing boiling water, the steam spreads in the surrounding region. This means that hot gas spreads everywhere. Then why doesn't the hot gas in the star disperse in the space? It should go everywhere in the universe. And why have the properties of the sun remained unchanged over the 4.5 billion years? And the answer to it as the gravitational force. As we have the Earth's gravitational force, similarly, stars are also having their own gravitational force, which holds back all the hot gases in the star. Now, you can see over here with the picture they have shown over here, you can see the gravitation is pulling it inward and the pressure of a hot gas is taking outside. So two forces are acting together. The one is inward, that is a gravitation, and the one is hot gases. They apply a force on the outward direction. So these two forces, they are capable of maintaining the size of the star. Whichever forces are higher, definitely that will give the final result in the size of the, or to explain the size of the star. Further is, we have to study about the evolution of stars, which we will see in the next lecture.